Hi, folks. I'm audible. Can you guys hear me? Okay, okay. Hi, Raksh. Hi, Harsh. And those who have joined us from the YouTube. Just okay. So today, in the session, we will be talking about Docker, Docker Compose, and in general about virtualization, containerization, and so on. Today's topic mostly focused on it. And before we start, have you guys ever worked on, ever heard about Docker, Docker Compose, or any container, virtual machine per se? You can unmute yourself and at least or say or just put the chat, put the comments on the chat. Okay, okay, cool. So today we will be reading about it. I will start. I think we'll start at 12:10, 2 minutes after this, and then see how it goes. Okay, okay. Is my screen visible? Okay, okay, cool, cool, cool. Yeah, yes. So let's start with the basic thing. Let's start with the basic topics such as let's talk about virtual machines and so on. Folks are waiting on the submit and all. Okay, okay. So let's go back to let me share my video as well. Okay, so actually change the- okay, no, not actually. Hmm. Okay, okay, folks. So, have you guys ever heard about the term system administration, or are you aware about how we used to deploy earlier back in the day when like maybe in 20s or 2000, earlier back when the cloud the back when the cloud was not that much famous in the face of engineers and so on. Anyone wanna put anyone wanna share something? Okay, there's mhm. No one. Okay. Okay, yeah. So earlier, back in the day, people used to have, their own dedicated servers on their own hardware, their own dedicated servers, where they used to, put their server, they should manage everything on their own. And somewhat I heard about getting, yes, 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 you're right, Rene. So earlier back in the day, people used to own the machines, the actual machines, and like that's how it used to work. We will have our own hardware, and then we will like the we used to have like network engineers in house. We used to have system administration. We used to make sure that all the things are working correctly. They used to manually install the RAM and the hardware, the CPU, and so on. Right now, nowadays, if you see it, just a it just a push of the button. Like you can just see on the console, and then we can right away we can change the CPU of the RAM, the everything that we have, right? It is like that configurable. We don't have to wait for a lot of time to like upscale or downscale our server. But it was not the case. People have come around. So firstly, let's understand the word DevOps, right? So no, it's not over. Sorry. Can you guys see my screen? Whatever I'm putting here. Uh, just waiting a minute. I think will not somewhere. Where am I? Okay, just a minute, folks. Oh, I'm not actually on the same board. Is it the case? Okay, sorry, I was on the wrong board actually. So let me share it again. Okay, think so now. It should be visible. Okay, cool. Yeah. So, okay. No, actually, this is not working. Let me share the thing for about this thing this time. Just a minute, folks. Let's see. 1, 0. Someone has messaged me for something for 20. So, just waiting a minute, folks. I think some issues are there with the screen sharing thing. Then, 1, 2, 5, 7, 8. The passcode for Zoom meeting is, I think, there's no passcode as such to, to join the meeting. I don't want to join. I just want to share my screen. Okay. Uh, share my screen. Okay. Okay. Somehow just stuck. Share, share, okay. Okay. This is good. Okay. Yeah. So earlier back in the day, there is a term that you might have heard much about, that is DevOps, right? And earlier we used to have a separate team, one for the development and one for the yeah, one for the development and one for the operations. One for the operations. So what used to happen was, the developers only used to do the development part, and the operations guys were used to you mostly the hardware folks, who should ensure that Houston. Okay, sorry, I forgot to call them again. Uh, and it was sorted. Okay, good. Recording has should be started. No? Yeah. Yes. So yeah, we used to have two separate teams. One team was the developers team, and one team was the operations team. And they used to ensure the web servers are working on perfectly. But as we move further with the new advancement, with the new requirements, there started the friction between the developers and the operations folks. Mostly because, for example, let's say I'm the backend developer, I need to request on certain setting down on server. So I have to go to the operations guy, and then I have to tell them, right? Okay, that I need this server which should have 4 GBs or RAM and this much amount of storage and so on. So earlier it was good, but back when things started growing faster, right? The it started it introduced a lot of friction between two folks, and the whole development life cycle was hampered in because of this, right? So then slowly people started working towards the concept of DevOps, right? So instead of instead of the need of the separate developer, separate operations team, they thought, why not let's have a dedicated team for the let's not have dedicated team. Let's have a single team which also does a backend as well as the cloud operations, right? For example, nowadays, so DevOps is basically a combination of two things. One is the developers, and another is the operations part, right? So that's how the whole DevOps thing started actually, in general. And since because now the developers are taking care of these things, we need control of the operating system in a way. How operations, because operations are only used to work with operations, like the actual hardware in general. Developers thought, why not if we can encapsulate this, if we can virtualize this whole thing in a single place in general. So instead of let's say actually allocating, let's say if I need a server of 8 GB RAM, right? And my host server actually has 32 gigs of RAM. Is there any possibility, I can actually use only 4 GBs of RAM for a dedicated server, and can we do it, right? And that's where things like virtual machines, I think you might have already heard about it. Virtual machines were the initial start, like where it's a simple concept, right? Where what happens is we have a host machine, and what we do is we put several machines inside of it on a virtualized manner. So I mean, you might have already tried it in one way or other. For example, if you are on Windows machine, you might have installed virtual machines, some software to run virtual machines, and you might have yeah, yes, actually the virtual box are the initial parts of it, right? But what happens is virtual machines are good. I mean, like you might have used some images, like I mean, you might have already tried it, right? What we do is we require an ISO image of the operating system, and then we can run any operating system inside any operating system. For example, if you want to run Linux on inside Windows, we can simply get the ISO image of the Ubuntu machine or any Linux operating system, and then on the there is a software called this software by Oracle, right? You might have heard about that as well, right? Where we simply put the IS image and then it just simply start that operating system, right? So while now the virtualization, I mean, it allows us to actually run any operating system inside any operations. The it becomes funny. It becomes tricky, like when we want to do like, the actual operating system things inside that virtual machine, right? Why? Because there is a virtualization layer already. I mean, so for example, what we mean by that is it's an abstract layer inside it. For example, Windows machine. For example, if you are running a Linux machine inside the virtual machine in Windows host operating system, what we would need actually is we want to virtualize the Linux system environment inside the Windows operating system, right? So the Windows operating system does not actually understand what the Linux operating system might require from the hardware part, but what we do is we try to mimic those things with the virtualization software in general. And while these things work for like general use cases, things become trickier when we want to do the actual when we want to utilize every juices from the virtualized machine in general. And that's where the problem comes because it is very heavy. I mean, if you would have ever run the virtual machine thing inside your operating system, you might have already felt the lag in the system because it becomes a bit slower in general, right? Now, how it is related with DevOps thing, we'll come to it shortly in general. But I think you got the point of the virtual machines in general, right? Now, now let's talk about a different thing. For example, I mean, we are all are software engineers here, right? I mean, we all have deployed one or other, one or other server in our production machines in general at some point of time in our life, right? So what happens is the simplest case is when sometimes simple things works in our machine, but the same thing does not work in let's say in a colleague's machine, right? Like we push a server code and then they just load the repository and they saying no, it is not working anymore in my system. And then you might have seen the famous meme where it's with the engineer saying it works on my machine and it does not work on the machines of the client side in general. So what happens is our development environment is different. Like the place where we'll be deploying the cloud is different, and place probably where the client will be using might be a different place altogether in general. So we want to tackle that part where we want to understand, how we can actually do we have any solution where we take care of that part actually in general, right? And can we use virtualization for that part, right? So what happens is Docker is basically service. As we talked about the virtual machine software side, Docker is something like that. In a very layman terms, Docker is very much similar to those virtual machines concepts in general. Just that it does not. It is lightweight in general. I mean, there are few technical differences between how virtual machine operates and how Docker image operates, but we are not going to deep dive into that part as of now. Not today, sometime later, but not yet. But yeah, they work on the similar principles. Like now, we have a concept of Docker images. Yeah, we were gonna jump into it. What are Docker images and so on shortly, very shortly in general. But yeah, there's a concept of Docker images. Actually happens is so what we're trying to do is the initial problem that we had, right? Or the initial problem was certain softwares are like let's say the server is actually working fine on my local environment, and but the same thing is not working on production in general, right? We want to tackle those scenarios so that we so that it should be like, if I have a package, it should work on any operating system regardless of the end user's environment in general, right? And that's where Docker helps us in a way. So what we're trying to do is we have a source code, right? I mean, in like, usually, let's say we're talking about a backend server, because that's where you will encounter it mostly, not on the front end part. So in the share the code. Okay, sorry, forgot. How do we do it? Yeah. So we have a backend server, and what it might contain is, there's a good chance it has a source code inbuilt with it, right? I mean, that's what we have on the backend, right? We have the source code of the application. It can be anything. It can be, it can be a Python based server. It can be Django. It can be, Fast API. It can be Flask. It can be Laravel, or it can be anything in general, right? Can be, I mean, the sky's the limit. So point is, it can be anything. What we want to do is we want to, how do we scroll down? Sorry, I'm just, okay, I think, okay. Yeah. So we have the whole backend part in general, and what we want to do is, actually, we want to, we want to have a an environment, or configuration which can be deployed anywhere, regardless of, where we code it. Like, for example, for the Windows devs, it should be same for the folks who are working on Linux or Macs. It should have the same environment in general, be it local environment as well as the production development environment. So no one says, okay, it works on my machine, it doesn't work on your machine again. So what we are trying to do is, we are trying to create a virtualization layer, and we're trying to create a package sort of thing, right? What that package will contain is basically, let me erase this part. Let me clean this up. Okay. Okay, cool. So what we want to package in general is, basically, we want to jot down things, as in, okay, there we go. Okay, cool. Yeah. So what we want to do is, we want to package things, like, we will have the source code, and what we know is, it works on it works on a given environment. So basically, it removes the dependence on OS-related operations. I mean, yes and no. Yes and no. Why do, why so? Let me quickly jump into it, right? So we want to package this. We want to, encapsulate the source code in a manner so that it works everywhere. That is the basic concept. What we do is, we pick up any image. We pick up any operating system, actually. We pick up any operating system. It can be anything. It can be, an Ubuntu based image. It can be a Debian based image, or it can be anything. I mean, you might have like Alpine and so on. So and then, what are these? These are just, some abstractions of Linux operating systems in general. And what we do is, we create those images in such a way that our source code is already installed on that machine, on that single machine, and all the dependencies that we want is already there inside a single image, right? So how do we run a virtual machine? We have an image, and then what we do is, we give that image uh, to the virtual machine, and then it runs out those images, right? The concept is similar. What now? Just that, instead of packaging the whole operating system, what we are trying to do is, we are trying to package our own source code inside, in a fixed environment, right? So that anyone who has Docker installed inside the system, they can simply run it right away. We will look into it in the, hands-on session, like later in the session. But yeah, we're talking about theories now, right? So we will pick up our operating system. It can be any operating system of your choice. Usually people go with, usually people go with Linux based images, mostly Debian, Alpine, or some sort of images. And what is Alpine, we will look into it as well. So what we do is, these were actually operating systems itself, right? We what we do is, we try to install all those things in a single file. So now, there's a thing called Docker file. What we do is we define everything inside a Docker file. I mean, we select the image, we select the initial image, select the initial image, uh, initial image is in like on top of which image we are trying to like write package our software. Can be Alpine, it can be Debian, I mean it can be anything, right? We have a ready-made images from where we can pick it up. Like nowadays, if you see most of the open source projects, they actually shape their own images, and we can let me literally use it and do something about it. For example, if you want to let's say I have a Python based server, what I can do is I can actually utilize some of the Python build images, and I can write my own. For example, let's say okay, let's talk about simple example in case of a fast API based server, right? So what we will do is I think it would be better if we simply, I guess it does not remove the dependency, just provides a virtual environment. It does not remove the dependency, it just provides a. Can you throw some more light, Harsh? So did not get your point. It just provides a virtual environment which works as all in one. It doesn't remove the dependency. Actually, I'm not able to get it. But what I will do is I will share my screen. And okay, stop share. Then what I will do is I am gonna share my screen. We will see how can we write the first Docker image. Let me open Visual Studio Code. Okay, okay, okay. So I will search. Let me share my screen now. Okay. It was a reply to okay. It was reply to my question, so which was not mentioned. Yeah. Makes sense. Yeah, actually, yes. And then I have to allow sharing. One second, screen sharing. There's control. How do we reclaim this thing? So the folks I joined from there and then lost the control. What notes? Not this. Or this. This tool. Okay. I will simply do one more. Okay, cool. I think I should be able to show it now. Okay. Yes, is my screen visible? Can you see my VS Code? I think so. Okay, so let's do one thing. Let's write a simple fast API server, and let's see how we can ship it up. How can we build a Docker image for it, right? So that we can run it anywhere. So let's say let's go to Google and say get started with fast API. Okay. Uh, we okay. So what we'll do is okay. So I did a Python based package. What we need to have is we should have a you might be aware we should have a requirements file, right? So let's make this thing requirement.txt requirement.txt and then requirements. Oh, sorry, that's and then that we already had. Okay. So what we want is okay, we want to run this simple command and let's try to package it. So this is a simple thing that our server does. And how do we do it? We should have a place where it says how to install it. Install. Okay. No. I mean, I know how like what packages are required, but let's see. Okay, intro. Get full name. Okay, let's do this. Keep let's get virtual environment. We can get virtual environment, but okay, I'm just gonna do it. Keep fast API. And we also need UVCon for this, right? So I think fast API is installed. And then we also need UVCon to run the fast API. So in the requirement file, let's just simply write that it is fast API, and then we also need UVCon, right? So we need these two packages to be installed, and then what we do is if we see, we simply run this. Yeah, that's fine. It is working fine if you open it. It's simple. It's a simple fast API server. We just respond with the message hello world and so on, right? So now what we want to do is we want to, let's say we want to deploy this thing. We want to we want to create a Docker image for this for this fast API server engine, right? So what we do is we create a Docker file, and then what we do is there are two ways again, right? I mean, what I can do is in the Docker file I have to write all the steps that are required to that are required to make that particular image. So in general, you might have simply, as of now, you would have seen that we did we had to install the requirements on the requirement.txt file, and then we simply have to run this command con and so and so, and then it will simply start running this thing, right? So what we can do is we can say, okay, make a fast API image. Okay. So there are two ways. One option is, let me just jot down the comments. One option is, we can use a Linux based image and install everything. Or second option is, if we can use Python based images. So the difference between them is both of them are actually Linux-based images. Just that in the Python-based images, Python will already be installed. In the Linux-based operating system, we will get a bare, bare Linux operating system image, which does not have anything. So then we would have to install everything from scratch, like by writing steps. Like for example, we're writing bash command, right? So we just had to write those bash commands here in the Docker file itself. So, for example, let's take just to this the time. Let's take some. No, they have okay. They have not done actually. Let me take my example. So, uh, 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 fast food, fast food, right? So Docker palette. So what we do is we take out things simply. Yeah. So we what we need is we need this kind of thing. So we say, okay, we are gonna use this image, right? We're gonna use Python 3.11 hyphen sleeve, and now again there are different perspectives of it. Like it represents a lot of things, right? So if you simply Google it, same image Python 3.11 same Docker image, and we would understand the difference between the different image that you might see. So there is one image called as Python 3.11.11, which will install Python 3.11 in Linux machine, and from there we can move ahead. Python 3.11 hyphen stream is a different image. It's again a Python 3.11 based image, but then it has different aspects of it. I mean, it is as the name says, right? It's the name Slim basically means it is smaller in size. If you go with the bare Python 3.11 image, it will be very large. It's like maybe like 300, 400 MBs, but Slim might be somewhere close to like 50 MB or so, right? And then we have different flavors of it. So what we can do is we can actually simply go to the Docker hub of the Docker page of the Python, and there we can see a lot of lot of different options that we already have available with us, right? So you can see, I mean, for example, let's say if we see, let's say Python 3.13, so we have different this kind of these all images are available for Python 3.13. Likewise for 3.12 we have different images, and if you see okay, so if you see 3.1, right? So that we have a different image for Windows Server Core, and then we have different image for Alpine. Again, Alpine also has a training image in itself, like 3.18. Then we have 3.123, and then Alpine 3.18. Likewise, we have different image for the slim bowl size, and then and like and slim buster is one image, one more image slim. This one image slim bookworm, and then and different images, right? Slim bookworm. So what we can do is if simply don't do, if we simply don't understand, we can simply just Google it. 3 point slim versus Python 3 point slim. Let's say what did you see bullseye? Bullseye. What was that? Sorry, Bulls and Bulls EYI, right? So the basic core difference is both are based on the Linux based like Debian based image like Alpine image, but the bigger place where they differ is actually on the Linux kernel that they are running, right? So like for example, yeah, Alpine channel. So yeah, I mean, yeah, that's the image size of using the smaller image. Like Alpine is one option, Stream is another option, and so on. Image there, no. Okay. We did not get the zero option. Since we did not get the yes for size of definitely for a very big factor in deciding an image. But yeah, compatibility things, right? So same buster built on widely used Debian buster and same buster boasts extent of compatibility for and so on. Alpine is a like very small image. It is a usually it is in the size of 2 digits of MBS in general. Likewise, for Bullseye, we have different things. But you see, no one has talked about it. Okay. Okay, I was expecting they would have written about it, but yeah. How they matter is they all have Python 3.1 installed in their operating system. The only place where they matter is the Linux kernel that they are running, right? So, for example, you might have seen that we usually get updates on our operating system, right? If you're running in Ubuntu, you might have seen it that from time to time we get Linux operating system updates, and sometimes there is an update on the Linux kernel as well, right? Sometimes you might have seen 4.13 was one of the kernel, and then the older versions of that the same kernel, and then a newer version of the same kernel in general. So they have given different options so that based on your requirement you can choose because there are certain requirements that typically depends on the specific type of Linux kernel. Uh, in general, you might not need it, but sometimes when the project becomes bigger and when we had to the project is let's say like 1 or 2 years old, then we have to ensure that we are choosing the image that actually supports all our dependencies in general, and that's why we need to choose this one, right? But yeah, so yeah, this is what we are choosing. When we write this command, like from Python 3.1 stream, what it actually does is it basically selects it basically selects the Python 3.1 based Ubuntu or Debian based operating system, which already has this installed in itself, right? Now, okay, let's copy it all in general and let's see what we're doing. So now we are trying to work directly, right? So work directly is something that we are explicitly saying to the the host machine that this will be my work directory. It does not it can be anything in general. Like it does not usually it might I mean it can be anything. Whatever you want, you can put it there. So what would happen is whatever command we will run will actually be in running. We will be running those commands inside this directory in general, right? Why do we need it? So that I mean, it is very good. It is a very good practice to specify it explicitly. Okay, this is gonna be my work directory where I will be copying my code and where I will be running my operations on. So yeah, we said okay, this is my work directory. So now from now on, slash app will be the place where we will be actually for example, you see this thing command like copy dot and dot, right? Dot space. So we have two options in general. I mean, what I can do is I can say, okay, copy main.py to as main.py. What it will do is it will simply copy this file uh, to something like app slash main.py, right? We said because we have defined this is a work directory, then when we copy this main.py locally from here, it will paste it automatically inside this work directory in general, right? So yeah, if we can do it in a an individual basis, or we have different option, you can simply say dot space dot. What it will do is it will copy everything inside this directory and it will place it as it is inside the slash app directory. So it is a bit easier. Sometimes it is it is easier to go ahead with, and sometimes we don't want that as well. Sometimes we just want to copy the files of our individual requirement and choices in general, and that's where we do it, right? So yeah, one thing will be okay. Let's do one thing. We copied the requirement.txt file. Requirement.txt file contains the dependencies of it in general. Then we okay. So again, when I say requirement.txt, that means the copy that is available locally. And when I say dot, then it is gonna copy it with the same name inside the work directory, right? Likewise, we can do like min.py and then we can put dot as well. So now what would it do is it will put everything inside those directories, and then what we do is we say okay pip install, and then this is a simple command that we know, right? For example, if you would be spinning up a new Python Apache Pybase server in an actual server, these are the command that we will actually run inside the machine, right? So that's what we are doing. Let's talk about the stage two things later on inside the inside it. And yeah, so what we did was okay, we copied all the files inside the image. We installed all the dependencies, and then we said okay, expose 8,000 in general, right? So what this actually does is, when this will be running, right? When this fast server will be running, it won't be running as it is running now. I mean, for example, when I run this command locally, this 8 port is actually this 8 port is actually exposed to this operating system, right? I mean, no one from outside world can access it unless and until I explicitly allow it, right? So, for example, if you work usually on the Linux operating system, you can simply go on the if you work specifically the Ubuntu operating system, you can simply say okay, you have sudo ufw allow, and then you can put the port so that from outside of your local system, anyone can simply copy the IP of your own machine and then your machine, and then simply put the port in front of it, and then they should be able to access whatever you're exposing on that particular port, right? So we want to do the same thing, right? Because if you don't expose any port outside, then we won't be able to access it from the outside, right? Because this will be running inside an isolated machine, right? It will be running inside an isolated pod. So unless until we allow it, we won't be able to access it, right? So let's say, okay, we want to expose this port, and then now what we can do is actually we can say run command, and then what it will actually do is we can say, okay, uvcon. We can put this command as it is, right? And which will ensure that we have it over. Okay, so yeah, it's that simple, right? I mean, we just to recap it, we picked the image. We said, okay, this is the place where we're gonna work. This is the context of the everything that we will do it with this Docker image. We just copied this file. We just copied this file, and then we ran this command where we are installing the requirements. So we said, okay, we're gonna expose this code, and then we say this thing. We are gonna expose this thing, right? So now, I mean, now I have this Docker file. Why do we need the Docker file? Because we want to create Docker image, right? Docker image will be created based on this part only. I mean, that is the only way of creating a Docker image, right? So now, instead of in case of virtual machines, we had a single image of the operating system, right? Now, we are Docker with the flexibility of writing something of our own inside the Docker file, and that is how it will create an image, right? So yeah, before that, I mean, obviously before we want to run this Docker once, we'll have to install Docker, Docker somewhere in our operating system, right? So you can simply Google, I mean, Docker install, and usually the Docker page will come up, which will have things, which will have instructions on how we can install Docker on our system, right? So, I mean, yeah, as of now, it supports the operating system, Linux, Mac, and Windows, and for all of those. For all of those operating systems, we have different instructions. So you can simply copy it and paste it out, and it will just work. It will just work fine. We don't need to do any fancy things in general. Just copy the instruction, and it will just simply work out. Now, so yeah, because I already have it installed, I can simply search the Docker PS, and I mean, and since Docker is already installed, I can see things. Let me just Docker stop this moment, folks. Yeah, so I mean, if we can run the command docker help to or docker version to see if we actually have Docker installed or not. Get this command done. Yeah. So you can run this command simply in your terminal Docker management version. It will give you the version where I mean which version is running on your operating system. If it is not installed, it will say Docker not found and so on. So what you have to do, you have to simply install it from their instruction and it will just work, right? So now, as of now, is this an image already? No, it is not an image. It is just a Docker file, which we will use to actually create which will actually use to create an image. So now what we do is, okay, we say, okay, Docker build. We run this command Docker build, and then because the Docker file is right away in this root directory, so as of now, let's do one thing. Let's just simply run this command, right? Docker build dot, and then we put something like, okay, let's say fast API test, and then we just put it. Let's dissect the command later on in general. So yeah, when we run this command, we will see it is doing some sort of things, right? So as of now, it is trying to pull this image from the cloud, which is so that it can it can use it, and then you will see all this command that we created, right? So if you see, okay, it ran this step, it ran this step, and then it ran this step, and now you will see it is now installing this part, right? Pip install blah 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 in requirement.txt. So it is installing all the requirements that we have, and as we run this command as well, right? Now it is doing this as well. Then yeah, so it will keep running. Okay, so one thing which I forgot is it will not end, right? So it will not end. So it's not going to end because it is waiting for the signal that it actually execute it completely. So we have to stop it. And then we'll have to do something like we have to do maybe entry point. Okay. Okay, good. So yeah, this is good to make an image. We'll show you how we can actually run this image in general. But you see right. So we ran this command, and now because it has cached all the things that it needed to cache, now you can see it has built that image for us. But right now it won't run it. So you can see the Docker. If you run the command Docker images, you will see we'll have it somewhere in as the yeah you see it, right. Fast dash is here, and then you will see it is just 156 MB or it is just 156 MB in size in general, right? So yeah, I mean it has created the image. Now if you want to run the image, what we can do is we can simply say docker run, and then we need to pass this image, name of the image that we have run, and then I think we have to pass some command. Okay, I'm not able to remember the syntax actually. So let's see, run docker images. Okay. So docker run, and then okay. So no, not docker images. No, we want to pass entry command. Pass entry pass entry command. Uh, no. Okay. Then okay. So no, I like no, this thing. Docker run. Okay. No, it won't run actually. I know. We had to Docker yes. It should not run. Yeah, you should not run, right. Pass start. Okay. No, run as yeah. Okay. 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 Yeah. So we simply do it, right? Okay. So the container, then it uploads the container, and then yeah. But no, it's just not going to do. Should always image name and so data and so on and so on. So where images of the brand minus the continuous food minus problem now. This as well. Let's see. Docker run minus myself best way. Since you're not able to figure it out. We'll see. Okay, so we want to attach this. We don't want to define the CPU. We want to do it. Don't want to run the test way. No interactive way. Okay, no label, no memory, no, and then publish, no, fill no, void, no. Do I know volume? No, and it is no. Okay. Okay, interesting. So, okay, let's do one thing. let's create a run test, and then let's start this UV on use a command again, recon, and then this. So we just copy it out, we paste it out. Then okay, we say what was that? Slash. We use some notation right on the sh part. Dot sh. Leave it. We're not doing it. Okay. So unicorn main app, and then okay. So this is what we want to run when we actually run it. Right? So entry point, and then we say run dot sh in general, right? And then we also obviously have to copy run dot sh to there, right? So the point with running juvicon command here is what it will do is actually it will be when it is trying to create an image, you have to understand one part, right? Every command that is executed here, when it exits, it sends some response to the process, right? Whether it has executed successfully or not in general. In case where when we put this thing, when we said okay run, and then we said okay UECon, and like no when we run this command, what was happening was it has installed all the dependencies, and now it is trying to run this, which will run fine because we obviously everything is running fine in general, right? Just that it is not going to end, and if this command does not execute successfully, we won't be able to have the final image. It is just stack, right? You getting the point, right? The Docker process is actually waiting for the process to complete, and so that it can actually build the image completely. But because we are running it right away, we won't be able to run it that way, right? So then we have a concept of entry point in general. Entry points are basically uh, basically a way of telling us to the operating system, okay, once this image is built, when we run this image, you actually have to run this thing in general, right? For example, if you see in the run sh file, what we did was we put the same command itself. We installed, we said, okay, we have to run this command, but as an entry point when we run the Docker image, not when we build it, right? So let's say when we build the Docker image again now, in general, we will be able to see it. We do this command again, docker build dot and minus c and then so and so, and hopefully it should we should be able to build it the image right away. Yeah, before that, since while it is actually installing, let's deep dive into this part. What does this part actually do? So let's say dot md, right? So, so Docker is Docker, right? Build is a command in Docker. Dot and let's understand this part, right? What does doc signifies, and then what does minus t signifies, and then what is fast API dot hyphen test, fast API hyphen test in general. What all of those signify and how do they differ in general, right? So, right now, Docker file is a standard name to Docker file. The Docker process expects us to have a Docker file where we are running a Docker command, right? Especially when we're trying to build a Docker based image in general. That's where it expects, okay, we should have it right away, right? So when a Docker file is, but again, we have the flexibility of naming it anything, right? I mean, we can like maybe say like dev.docker file or like build.docker file. I mean, it is on our end. There's no one actually restricting us from doing that right away. So what we do is, since we are using the default name, we don't actually need to pass a different name. Otherwise, we will see if the name of the Docker file is differs from the actual name. How do we actually build a Docker image, right? So what we're saying is, okay, this is the dot context. I mean, this is the context where I want to run this command, Docker build command. That's is actually to specify the tag. So, for example, whenever we build an image, I mean, let's say if we see Docker images, you will see these are the all these things, right? I mean, for example, this is the name of the repository, and this is the name of the tag that we pass it, right? So, this usually, how do we identify an image? We identify an image by this thing only, like fast API hyphen test colon latest. So latest is the default tag that we have, and fast API test is actually the name of the image repository, or you can simply say it is the name of the image in general. But usually it is coupled with the tag as well, right? If you don't pass any tag, by default Docker assigns the latest tag to it in general. So if you see, we did not put anything here. So by default, it is assigning the latest tag here, which you can see right away, right? Yeah, we are explicitly saying, okay, this is the tag that we want to put, so that's why minus t. I mean, what we can do is we can say we can do this thing as well. We can like do this thing as well, like test. I mean, it's up to us, and I mean we can do anything with it, right? Likewise, if you see, so these all these images, right? I mean, these are nothing but tags actually. So when we say okay, so when we will use it, this part let's come back to a Docker file. So when we say Python 3.11 hyphen stream, right? What it is, again, it is also a Docker image in itself, right? The Python is the name of the repository, and 3.11 hyphen stream is the name of the tag that they have given for this particular kind of image. Likewise, we can, I mean, it is up to we can do anything with it. Just to show it, we can simply okay, we will run the same command and we will see we now have this image. So when I run Docker images, you will see I should have two images, two different images. One is with the data tag, one is with the temp tag in general. And likewise, again, I can run the this as a test, and it will. I mean, so yeah, it is up to us, and just you can how you want to name it is up to you. I mean, there is no specific standard like nomenclature system that says okay, this is the only way you have to do it. You are free to do define any tag that you want to. It should just be a valid name in general. It should just be like a valid string or literal in general. And then no one is restricting you from defining any of your type, right? Now, let's say if the name of your Docker image was something else, like something else. Let's say it was Docker file. I mean, it cannot be the Docker file. I mean, it can be anything, right? We can literally have anything is in. So I can simply say, okay, this is my Docker file, and it will just work fine, right? Because there's no validation on the like name or file name or the extension name that we have. And you might have seen it should just be a valid textual file from which the Docker process should be able to read the file, nothing else. Now, because we have changed the name of the file, now Docker build dot should not work. So if I see this, you'll see okay. So see right. Fail to resolve, fail to read Docker file, open Docker file, no such file or directory. So when we put dot, it is expecting a Docker file inside this root itself. But we don't have any Docker file, right? So that's why it doesn't able to build it. Now, how do we build it then? In this case, so what we do is we explicitly state that okay, minus f, we say dot dev dot Docker file. Now we should be able to sorry, okay, sorry, minus f, okay. Minus f. Uh, Apologies. Docker build minus 5. Yeah, see. Okay, minus f final. Yeah, that's what we were doing, right? Minus. Okay, minus f and then we were doing it right. Minus f and then this is what we're doing. Docker build exactly expects one requirement. Docker build startable. Okay, so I think I'm already the syntax. Build a Docker image with custom Docker file. So we will see, should be able to just similar. Hmm. Uh, Docker build custom Docker file. Custom Docker file. Uh-huh. Okay, so I should have an ops here and then should have a scripts build, build, build. I'm doing anything wrong. Okay. So Docker build minus f and then we see minus f and then it should be a file string, right? So path and then Docker file. Oh, sorry, I think we need this as well. Okay, cool. Sorry. Yeah. Cool, cool. Yeah, right. So we were right. In general, we need this dot as well. Stating we want to run this command right away, right here in general. That's why we need it. Even if we, yeah. So I mean, that's why we need the dot here and then. Sorry, I thought I'm putting it right away, but we're not. So yeah, now why do we need to put the dot there? Is again that is a different command now. PC, right? So now again we are telling we have to run this. We have to run this command from the context of this thing, right? If you see the Docker file in general, right? What we're saying is that let's just put it here. Okay, let's put it here. Okay. Okay, yeah. So if you see, we are trying to we have put commands such as copy requirement.txt and then put it inside the work directory, right? So now the context that we provide, so because this Docker file might be somewhere, right? What we are ensuring with dot is we want to run this Docker file from the context of here. This Docker file can be in anywhere. This Docker file can be inside different directory in general. It does not matter much. But this context, this dot context is involved so that it actually picks this main.py and then it puts it inside this directory in general and not any other different random file, right? So that's why we need this dot. So yeah, that's how we do it. If we have a custom name on the Docker file, we simply say okay, and then you will see we still have the same image. We still have the Docker image with us, right? Which was built some time ago. And one good thing which what with this thing is it actually caches everything, right? So the all the steps that we put here are actually cached in general. So when we do the Docker build command run, if we run it again and again, if it detects that there is no such change, it will simply it will simply not rebuild the whole image just for the sake of rebuilding it. I mean, we have a way of doing it as well, but yeah, we're smart enough to understand. Okay, this part is something that does not require us to rebuild the whole thing again. And again, all these individual commands are cached as well. So, for example, let's say, for example, if you see, if I run Docker build, let me revert it to the original names, rename, and do this. Now we'll do instead of this, we simply do this. And now we should be able to build the Docker image. We are able to build the Docker image, right? Now it is not doing anything extra. If you see all the steps, right? I mean, the step two is actually this is work directly slash. If it is again cached, see it is again cached, this is again cached, and all the steps are already cached in here. So Docker actually builds these images in multiple parts, and these commands are these are individual steps, and it actually caches the individual things in general, right? So what happens? Let's say if I actually change something. If I let's say if I added an answer, now if I run this thing, you will see it will now build it again. So right. So till now the requirement.txt it was cached, but post it since it was not cached, it will again do it. So if it sees that okay, this step is something that got changed, so what it will do is it will subsequently run this command again in order to ensure that we have an image that is actually consistent with the code that we have put, right? Now how to run it? We can simply say okay, docker run, and then we can simply pass the name of the image. In our case, it was this, and we'll do first rendering kit and able to start containers and notice it execute the file not found in the path. Okay, sorry, we had to do something like this. Okay, so we'll have to build it again. So why do we need this? Because it is I mean inside our shell we can actually I can simply say dot slash and annotation it will simply work fine. But inside the Docker image usually we have to be explicit of what we want to do. Right? So we have to pass an image and now I think should work fine. Uh, Executable file not found, failed to create. No, what was the image temp and is it the Docker images and then we have the temp as well. Was by temp. Okay, so it is the same image, just that this thing. Okay, okay. So let's see. Docker's entry point not working. It says. What does it say? Docker run. It says that. this container. So let's just copy this part and let's Google it. We content to go the document is not working. Okay, yes, this is okay, so we already have an email issue for it. It is a simple issue, but we must have it now. So and then we do it. Uh, 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 it is a okay, okay. So before this thing, process. Ah, interesting. Okay, so let's do that as well. So what we're trying to do is essentially we're giving it the executable permissions in the right CMS mode plus X and then we say run dot sh and hopefully that should go. So by default it does not have the permission to run this thing right away. So then we run this. No, not this thing. .NET no. Then okay, interesting. So CH1 goes. Let's read the documentation. Docker and see on documentation. Let's try to figure it out. Docker reference. Docker file entry content. Specify default executable. So yeah, okay. So it says okay. So what it says is allows you to configure a container that will run as an executable. Doc entry point is two possible forms. Next part is sorry. We will this. And then the shell form is okay. You can pass the command and then this how it will run it. Blah, 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 blah. And then, okay, we have to configure out the port as well. And then click on same. Okay, let's build it again. Now let's run it again. Now we will able to run it, right? So, yeah, syntax error again. Now, if we try to access it, is it we're not able to run it in general, right? Because this is actually running inside an operating system. So, for example, if I simply split my terminal and if I see let's roll this out and let's see. Okay, Docker, yes. So you will see this is running. This image is actually running inside it, and this is the command that is actually being run. And is any way to okay. And 88 port is actually open, right? Now the reason why we are not able to access it is because we are explicitly not we are not attached like no outside port and inside port. So while 888 port is actually like open to the world, we have not set because when I run this command, when I run this command, it's trying to access 888 port running on my system, not inside the Docker container, right? So what we do is we close this out. Let's say we what okay, wait, no, no, actually I think something weird. My system, something wrong with my system. I think let's just close it out. And then I simply do this again as well. See if it is still running. Okay, yes, it is still running. So let's go it out first. Stop, and then let's put the ID. Okay, now I say Docker yes, nothing is running. So now I see Docker run, blah blah, blah. And now I attach ports as well. So I say 88,000 port colon 888 should actually do it. So by specifying minus port here in general, now so earlier command was this Docker run, and then we said okay the image name that is basically this, and then we said okay minus earlier we were running it that way. Now we are saying okay now we are saying okay 8,000 to 9,000, right? So what both of these mean actually mean is 8,000 we are attaching the 8,888 port of our system with the 888 port of the Docker container. Now if I refresh my file, I should be able to access it. So okay, it should work fine in the interesting. No, so usually it works fine on Linux, but for Mac, I think we have to do one more configuration to allow it. Uh, 8,000. We have exposed it as well. There's some, I think, some issues with my system today. Really does not take that much time, but yeah, sometimes it just happens. So a Docker run minus p minus minus l. And sorry, let's understand this part. Oh, is it minus minus port? Docker run. Okay, let's simply do this. So okay, so no. Okay, so I mean that is not the correct way of passing it out. I think that's why it is erroring out. So host name, then IP string. Now we are going to do that. Not going to publish this. Publish a containers port to the host, and then okay. So minus p is the one way to do it. Let's see, Docker run documentation. I will see one ports. Do we have it somewhere? Okay. No. Docker run and we'll see minus p. Minus p. Do you see any? No, okay, no, we don't have it. So keep it again, we don't have to touch it. So I mean, these are different options with which you can like no, explicitly say this is the like the CPU and then which you want to configure. But as of now, we are not going there. As now we want to simply attach the port to it. So port, expose ports. You can start the container with minus p minus x to expose it first, minus p x position will expose to the host. So Docker binds is exposed put from the to a random port on host. Now we don't want the expose it will just put on the explicit exists port. Okay. Fetch that you explicitly map a single port, range of ports and container host port. Okay. But do we have syntax of it? Exposed ports and no, we don't want the environment. So uh, mm, minus p only if the using out of measure on minus also talking command. Okay, Docker run, let's just do it. Docker run with port. I mean, expose is something that you don't want. You only expose it on a Docker file. You simply run it with a Docker run. I'm not expose to expose. Okay, expose multiple Docker ports published. Minus P, it is current. We're doing it right. We Docker run and then we pass the image and then we also say it's minus P and so and so. Okay. Uh, Docker run this. Again, this is something that you will face mostly in Linux, mostly in Mac. I have not faced this thing in Linux and I have read one article, so I'm not able to recall it, but this is how it works. So if you see here, you'll see that, okay, there are two codes that are in, okay, and then, but yeah, they are not actually attached with, not able to use Docker codes on Mac. Docker learning, but okay, so refuse to expose code. Okay, some known issue. SP if Rahul. Okay. So Docker run and say publish code and open it. Yeah, and we use code there two conflicting parts. So Docker run minus B check your port bind to this not done. Oh, so okay. So comes to the network. What you're running the container? Log into the container and use okay. Says localhost should work, but we seem to it does not. And I think 0.0 should 0.0, 0.0. No, we don't get it wrong. 27.0.0.1. Again, the same thing. Are we having anything? Let's do one thing. Let's close it out. Let's go to terminal. Let's docker stop. So how do we stop a container if it becomes rogue, just like mine? You simply run docker stop and then you just put the container ID, and then you should be able to run right away. We should be able to stop it right away. And even if it refuses again and again, so we again have an option to force it. So we can simply pass the flag minus minus force, and then it will like stop it it will force that it is basically stopped in general. Now see, okay, uh, docker run, see, docker run, test, okay, it's fine, but we don't want it that way. Again, Recon running on 888,000 port, but we still not able to do. So again, sorry, folks, it is not working on my system, but this is how it usually works. But yeah, that's what it like to do. Sometimes things don't work right away, and you have to figure out. What to do. So okay, but they should be able to do it all the time. They should be okay. Let's ask ChatGPT in general. I am not able to run top. Okay. Let's pass it this command. So it knows the context. I am running the below command, and this is my Docker file, which I will put as this. This is it, right? And the sh file as this inside. When I run Docker run, it does not find 888 port to my systems. 888 port, and let's see what ChatGPT has to say about it. This is a custom. Oh, okay. So our order is actually wrong. Interesting. Oh, our order was actually wrong. Okay. So we just stop it, stop, and then we do this. So, yep, let's say correct for now. And are we able to use it now? No, we are not able to. 0.0.0. No. And then local same, right? Okay. The workshop Docker can interface split this conflict. No, I am not able to run it. Okay, so then let's ask it again. Professional. We have Docker image, rebuild Docker image. Okay, so this might be one of the catch. Actually, okay, makes sense. Close it out. Docker, Docker images. Docker build, Docker PS actually. Docker stop. Okay, and then we save the Docker, and then we say run. Sorry, Docker build. So the difference between the difference between the earlier command and the now this command is basically Docker is running, but it is not actually, though it did it did port is exposed, it is not actually assigning it to the outside world. I mean, like, uh, uh, this host plays very important role here in general. Now I think should be able to work if we don't have any other issues with it. We should be able to get it to work in general. Yeah, now you see, okay, and now is it, yeah, now you are able to see, right? It is working just fine in general, right? So this host was the culprit in our case, and Mac was not. So because it's next. But yeah, yeah, and now we are able to now we are able to use it right away, right? Now the thing is that now you see the Docker image that you have built, right? And now if I close it, yeah, I mean, should be able to, yes, I mean, should the Docker control C command for some reason, but we can see all the commands right here, which is like, working fine in general, and we can see the Docker in, not here, Docker images. And you will see that, I mean, if anyone has this Docker image, I mean, in their system, they can run the exact same thing that we are having as of now. It won't, like, no matter if it is Linux, if it is Mac, if it is, Windows or any other system. You can actually do this. You can experiment it right away in your, like, in your respective operating system and choose your in general, right? So yeah, as of now, what we saw was we were able to, simply create a Docker image first. We were able to, like, run the command. And the difference between run command and enter point is run command will run right away. Enter point is something that will run when we actually run the Docker run command in general, right? And we have one more command. I think that is called as CMD. Let's go to documentation. Let's go through this, the CMD, just the spread default command. So simply instruction sends the command to be executed when running contains from minimize, right? So whatever we did with the entry point, we can also do it with the CMD as well. We can put the CMD, and then we will have the same result in general, right? So both are like, both can be used interchangeably. If you want, like, to run the same execute every time, then you should consider using like this. So yeah, we can also use it to do it, and that's how it will work in general. Now let's see how we can, like, quickly set up a developer. I mean, yeah, this is one way of doing it. Now, what usually happens is, like, whenever we are running it on production, right? What we do is, on the CI/CD pipeline, what we do is we actually do the Docker build command, and we actually push it to a repository where those images will be hosted, right? For example, Docker Hub is one place where we can have it. For example, if we see Docker Hub, hub.docker.com. So by default it will try to push it here, but yeah, but different services have different options. If we are going with AWS, we have a different, they have a dedicated service called ECR, like, I think Elastic Container Repository, where we can, like, push Docker images right away from our local system to, like, the AWS cloud. Docker Hub is just the default service that we have. So for example, if you can see, these are my images that I have portrayed, which I have published in general. And then again, we have an option to make them public or private. So I mean, the images that I use are, like, actually few images are not few images are private, and few images are public, and so on. So yeah, I mean, the public images can be used by anyone. For private one, obviously we need authentication authorization to ensure that you can actually access those images. Likewise, nowadays, Azure has its own image repository service. GCP has its own, and DigitalOcean has its own. And you can use any of those services as per your, like, as per your choice, and they will just work fine. I mean, they are just, like, no repository to store the images and anything else. So I mean, that's how you can, like, simply make it work in general. And how do we push the images? We can simply, okay. So to do is simply run Docker push, and then we, like, write the name of the image, and it will actually push those images here. Because I have logged in with my account in the local Docker, it will push it on my system. Docker push, and so on. Yeah, so we can actually run the command, and it will simply, push it here, right? And how does it know that you are you? We can simply say Docker login, and it will actually open the Docker app. Yeah, I mean, I have already logged in, so it identified me. But otherwise, it will open a pop-up, and you will have to log in, and that's how it knows that you are actually here. This is only for the Docker app. If you want to push Docker app for different mechanism, we have different images. If you want to push it to Docker, if you want to push it on ECR, they will give different instructions on how can you do it. Likewise for Azure and DigitalOcean, image repository and so on. So the the Docker push command will remain, though the Docker push command will remain same. The Docker login part will something that will actually change when we are trying to push it to different image repository, and rest everything will remain similar. So if till now any questions, if anyone has, or we will move ahead with the next things. Okay, okay. So I think I don't see any questions. So let me just find the next. Just a minute. Just a minute, folks. So how many of you have faced an issue where you have to install the for example, let's say you want to run Postgres with Django or Laravel or Node and so on, and then you have to install those things again and again when you are trying to run those projects locally, right? I mean, you have to install you have to install the Postgres again, you have to install the Redis again, and based on our every different service, you have to do it again. The worst part with that is the moment we switch projects and if you want still we're using the same tech stack, then we have confusion. I mean, we have to change we have to reset the database passwords and and so on. I mean, that is how we do it, right? I mean, we spin another new database in Postgres server and then we run those things manually, and that's how it goes, right? But that is not very feasible. I mean, you can still do it, but sometimes it is frustrating if you're working on multiple projects at a time, and especially for example, you're a service company and you were working at multiple projects at the same time, right? So it becomes tedious for us to do those manual steps again and again, and that's where that's where we we want to get some help, right? But before that, before we move on there, we also have an option of running it as in detached mode, right? So if you see, when we ran this command, it was actually showing us the it was actually showing us the logs right away. But if I run this thing, okay, docker ps, docker stop, command control C will actually stop the server. But I think for some reason it is taking some time on my Mac. As of I don't know. We'll figure out later, but yeah, control C will do it, and you don't have to do this step again as I'm doing right now. But so that yeah, you don't wonder why this is still running once you place it. So one option is what happens is we want to run this image in a detached manner. What do we mean by detached is I don't want to keep following the logs. I can simply do this right now. If you see, this is actually running, right? It's actually running, and I want to for example, just to prove this. If you refresh, this is actually running. I mean, this is actually literally coming from the Docker image, not anywhere else, right? But how do we see the logs and so on? So we have basic commands of Docker, which we can use it to, which we can use it right away to see the logs, and we can actually go inside the machine itself, and we can run any of the commands that we want that we would run in any Linux server and so on. So what how do we do is we run a Docker ps command, and we see the container right there. As you see here, you can see that this is the image that is being run. This is a command that is being run, and different things are already. So let's say what we want to see the logs, right? So we can see we can run this command docker logs minus. So let's start with this docker logs, and then you can simply put this command, right? Docker logs and then the container ID, and it will give me the log, the current logs in general. But if you see, it will see me certain latest lines of the logs, not the it is still not following it, right? What I can do is I can say docker logs, and then I can say minus minus follow, and now it is actually following it. So example, if I hit it again, you will see, yeah, if you will see the logs getting created right away, right? So this is a live logging that we see from the container itself, right? So it is actually running inside the container, but we are just streaming it outside. So we can do just by passing the management follow command, we can actually do it. Likewise, what if we want to actually go inside the machine and execute something? So for that we have a command docker, and then we docker exec minus it, and this is a form of the command, and then we actually do something like sh. So what we're actually doing is no, actually we are inside the machine, not we're not outside the machine, right? I mean, we are inside the container. This command is actually not being run in my Mac. It is actually being run inside the Docker container that we have just created, right? So example, what we're doing is this is so yeah. Again, for example, as we saw the minus follow command and like with the logs, right? With minus follow command, it actually streams a log out to us. Likewise, if I let's go to the machine. If I want to run a single command at one point, right? I mean, if you don't want to keep inside the machine, I can simply do this, and you will see. I mean, it did not run anything. So I can say echo hello world. I mean, running this command inside. Okay, no, yeah, right. So this command is actually being run inside this Docker machine in general. I mean, so I'm running this command, but I'm just getting out. I mean, so for example, there might be times like where we want to do one-time gigs, and there might be times where we actually want to go inside the machine, like take control and do things for a longer time in general, right? So at one point, for the single shot commands, you can simply do this docker exec the container ID and then run the pass the actual command, and it will just work. It will just run the command right away. The question comes is where are we actually running this particular piece of command? So you remember the work directory that we created? It is running this command there actually. And in a way, for example, if I want to if I don't want to, if I actually want to go inside the machine, I can what I can simply do is I can simply say okay minus it. Minus it is actually specifying that is we will be running this thing in an interactive mode. So it won't actually push us out. Rather, we will. So I want to run this command, and what command do we run? We simply state the name of the shell that we want to use, right? So, for example, if I say bash, it will. Okay, so I think bash is by default not supported. Uh, yeah, but sh is okay. So exit. Okay, so okay, so you're doing it wrong. Um, the command is wrong. Yeah, but she supported that. You can see. Yeah, so you can see, right? I mean, we created this book that there slash app here, and we actually when once we run an handling command, it just puts us there, and you see all the files that we had copied is actually inside this machine and not anywhere else in general, right? So I mean that is how we identify, and then I can done anything. I mean, I can say okay, I can say you can go inside slash etc, and I mean it is a like a legit Linux environment in general. And the funny part is, I mean, whatever I do here, it won't affect anything inside my machine, right? For example, just to show the context, what if I say okay rm and then I say okay main.py. If you see, now I don't have this file anymore in general, right? And probably I think this should also, yeah, okay, it is not filled, which is a good thing. So it has not yet rebuilt, but now the file does not exist in general. Till this process is running, till the UBCon command is running, I think this process won't fail because it has already loaded that file probably in its memory and so on. But the next iteration will be fine. The point is now we have a clear isolation. I mean, anything that happens inside this machine is totally isolated from whatever is happening right away. So, and that is why it is easier for me to build, it is easier for me to spin up an environment, right? For example, when we are working on a production environment, there might be possibility where we want to spin up, the servers fastly in general. And that's why I don't have to do anything. I mean, wait for longer. I can simply, let me just build a Docker image. Again, Docker build. And then, now, I mean, I have the image, which is like just working fine in general. And yeah, now I see Docker images. I can see I have new image created right away. I think it has cached the contents of it, so it has not created new image one. But now if I use that image, let's say if I, but for that I have to stop the older image Docker ps. I stop it Docker stop, and then I pass this command in general. And now we have stopped that command particularly. And once it is stopped, we won't be able to access it the moment it stops it. Yeah, now we won't be able to access it right away, right? Because it has stopped that container from being executed. So I mean, this is how we these are the basic commands which are like typically helpful when you are working with production environments, like getting inside and outside of the machine, and having a real time log streaming from inside the kernel to the outside world is important. And these are one of the few basic commands that you should know. Again, you have different options of attaching volumes and different things are there. But today we won't be digging more inside it. Let's move ahead with the different thing that I wanted to that I wanted to convey here. So yeah, I mean, till now are we clear? I mean, any questions, any any say I mean yeah, any questions or interviews that you want to ask or something? If not, we can move ahead with the Docker Compose actually. Okay, so I am just seeing those messages now. So I mean, yeah, I mean, let me know if there's anything. Just unmute yourself and just tell me that okay, you're not able to see the fonts and so on. So I will increase it. Hmm. Okay, no, now so now this is well and this is good and fine. What if I want to just run multiple things at the same time? I mean, multiple things as in I want to, let's say I want to run the database, I want to run the cache and all those things with the Docker file. I mean, running these individual commands are, I mean, while they're good, uh, if I, we are happy with it because we are running a single service. The moment we increase the services, let's say 3 or 4 services, we won't be able to run it in a sustainable way, right? We have to run this 5 6 commands in 5 different places and ensure that okay things are running in general, running fine or not. So that's where we got to know about the Docker Compose. Docker Compose.yml. So again, Docker Compose is again by Docker. What it does, it actually helps us in utilizing or deploying these Docker files in a better way, right? So till now, till the Docker build part, nothing has changed yet as of now. How to maintain Docker images version, how to identify previous version. So I mean, the moment so it is up to us in general. I mean, like, whenever we run the Docker build command, we can dynamically pass the image. So I mean, I just had to at this time, this is the tag, right, that I'm giving. So you can say okay, Docker one, and then you can build image that will have Docker. I can make it two, and then and so on, right? So all these images will actually be pushed right away to to your repository, and that's where all these images will be restored in general, right? So I mean that's how we try to maintain it. I mean again, though there is no such nomenclature. One nomenclature that I prefer to use just to identify it by using the dates in general. So how do I actually how do I actually use the name the tag of my image? Something like, for example, fast API here, something like this. And for me, it will be, for example, today this year is 24, right? 24 dot this month is 4, and then today is actually I think today is what date is today? Today is 13th, right? So my mistake would be something like this: one, and then two, and then and and things like that, right? So why I do this? I mean, you have to do anything that you want to. You have to do anything you want, right? But how it helps me is just by looking at the image tag, I'm able to identify which image is it actually from. When did we actually build that image? And I don't have to look at the I mean logs and so on. It helps me narrowing down the window. For example, when I see that okay, certain deployments are failing, which were deployed on that particular part, I exactly know what we did that day and what things we pushed to production and how can I roll back to the previous version. Again, this 1 2 3 are just the what we can call it more like the the counters in general. So that in a single day, if we have multiple push, we are able to identify that as well in at some point of time. The better option would be if I put some timestamp as well, the unique timestamp. So I'm able to identify it uniquely so that because every time it have unique timestamp, I have a single place where I will be building image at single point of time. It will be building a single image there. So again, based on based on your requirement, based on what you feel is right, you should be how you should version it that way in general. And again, these are not versions; these are tags, right? I mean, there's no like version like this version 1, version 2. It's more like that image was there and not is a different image. I mean, and there's no linkage between them other than just as they belong to the same repository, and the tags are the only way to distinguish between two images. If you don't pass a tag, then by default Docker will look for an image with with the tag latest, and that's the default behavior of it, right? Coming back to Docker Compose, right? So when Docker Compose, what people identified, what people figured out was like while Docker is good, when we deploy multiple services, it is not that helpful for us, right? So what they did was okay, let's compile everything in a single place, and that's how they came up with something like this Docker Compose file, right? It is a YML file where we define all the definitions. I will simply copy this part for now, and I will explain it in general. So if you see here, what we're trying to do is again, uh, I have defined a MySQL server, I have defined a RabbitMQ, and again, these are the Docker images in there, right? These are Docker images that are there, which is being pulled from their respective repositories. By default, we are not configuring anything, so it is being pulled from the hub.docker.com. Right. And likewise, I can simply, so as of now, we have three services. I can also say, okay, I can say CMS and then I can say backend engineer. And then I can say again image and then I can say, let's say, what was the name of our image? It was this. And then, and then test. Sorry, test or temp. Okay. Temp, I guess. Yeah, okay. It was test. Okay. Okay. Right, so I just had to pass one, and I don't. I mean, yeah, I can simply say okay for the ports. I can say that I want to test 8888 with 8888, and that's how it will do it. Let's come to this part later on. I will tell you what those are in general. 66, and again, do you have any more images? Okay, yeah, well, let's keep it that way. Now we'll also run this part because we're doing it. Just give me a sec. So I will come back to I will explain everything, right? And then we have the Docker file and then various images. So yeah, now let's look at this. Let's look at this Docker Compose, this YAML file, right? Version is alternative to put so that the Docker knows, okay, well, I think this file was compatible with which version in general. I mean, 3.1 is 3.8 is limitation, so I mean you can safely use it, and I mean you wanted to change it. I mean, like for a longer time now. It's just whichever versions are, it just works fine. It just works fine, right? Now, if you see this is a MySQL server, what I'm doing is I have posted. Okay, I have stated that okay, this is the this is the image that I'm gonna use it. Again, you can pass it like this, or you can pass it like this. It does not matter much, right? Like, I mean, you put quotes, you don't put quotes. It does not matter, especially the image part. Later in different places it might matter, but not here in the image name, right? So I have to specify the name of the image that I'm going to use it. Again, the hierarchy, right? For example, how what happens is when we run Docker run or now how we will run Docker Compose, right? In general, is whatever image you have put here, it will try to actually look for those image locally, and only if those images not available locally, it will try to look on the configured hub in general. So if I don't have a, let's say, okay, so if I have Docker, let's see, if, do I have that MySQL image? Let's see. So if you see, I have the Postgres image, I had the RabbitMQ, I think I might also have Redis. Yeah, MySQL is already there, right? So because I have those images already available locally, it won't actually pull it from the cloud, and that goes same for the fastly dash images, right? It will first look in the local repository, and it won't actually find the Docker. It won't if it won't find it, it will actually look for the same image with the same name in the Docker hub in general, right? So yeah, that's how we do it. Again, the configuration things, whatever we would have passed it from the docker run CLI command, we can actually define those in a single place. I can, like, for example, I can attach the volumes, I can attach specify the ports in a better way now, right? And now if you see, now I won't be able to commit the mistake that I was committing earlier, right? Earlier, if you would have seen, the placement of minus p was important. We were placing it like after the image name, and that's what the issue was initially. So yeah, you get the point, right? I mean, the order of this does not matter. Unless and until it is inside the defined scope, it won't matter much, and it will run just fine in general. So yeah, this is how it goes. And what we can do is we can actually simply say instead of docker run, now we have to say docker compose and up, and yeah, and this is what we do, and then it will actually run all those things. It will run all those things right away in general. So yeah, you see, it created a network, it created the RabbitMQ server, it created the MySQL server, it created the backend, it created the Redis, and now everything is working fine. So yeah, so I think MySQL failed. Repetition container, container, executable, then dot sh, MySQL, same as MySQL, and then oh, okay, graceful shocking. My entry points before MySQL query started. Entry point n. Oh, interesting. We don't say that we look at post file and MySQL port. Okay, let's do one thing. Let's copy the replace. Shut off. Playing with it. Paste it out, and then although I think the port was only different, but I think it won't matter much. I mean, it should still fail. It should still fail. Yeah, it is still fail, right? So it says that entry point save for MySQL. Let's use the latest image. I think there will be some different configuration that I'm missing out. So it's commented host where? Manish? Exactly like where? Have I passed host? No, I'm not passed host. Right? It is failing because it is looking unable to start container process, access, execution. Run.sh, execute not spawning, path unknown. And environment is there, environment file is there. We have not passed any entry points file. So let's go with this. And issues my 8.3.0. I think by default it is also using okay 8.3.0. So 8.3.0. I can pull that image again because it does not have the 8.3.0 local. So you see, right? Because it does not have that image locally, it will pull it out, and then it should be able to use it. Okay, they already given it. Command, this is what they want, and this sort of is. I mean, should not have- so it is able to run it. Fingers crossed. No. Is it because of the run.sh file? Was runs given to start containers. Okay, just endurance before started. I mean, I don't have any 3 point scripts. Am I passing anything? No, I'm not passing anything. Okay. Okay, let's debug it. Let's say command default authentication is something that you can pass over for sure. Let's see. But no, the issue does not solve the issue that we are looking at. So in .env, do you have anything that we should not? MySQL is there, MySQL host is there, password is there, MySQL user is there, and then nothing. Okay. So if we do, okay, let's Google it. MySQL Docker Compose. The rest is missing from the container image. The rest is not executable. Is not on the okay. So by default, it should not be there. Let's rename this thing. Directly rename this thing to start as so that, but it should not pick it up as well. But let's fix it. And then we had the docker file image, and then start.sh. The show field does not interface with it, and then we do docker build again. So we create a new image, and then okay, let's start. We can show only dependency computer to it, kind of. Mm. CS mode plus okay. Uh, okay, so we have the image. Now we see Docker Composer. Interesting. Mhm. Okay. Okay, so it says that receiver is on one path and non-seeking Docker is able to find the only. This one may not exist in the container image. What what does my SQL actually do it? I don't think so. Okay, let's show it. Let's run the command that let's basically pass it. And then okay, then let's restart all this. Fix. This is really into Docker Compose file, and then we have MySQL use this okay, and then this one AFI says command is using normally OEM says. What's that? I think just in the code for now. Full format. Okay, okay, okay. I'm getting the same for different image for the different database. Something that I think. Let's see. Does it do the same for Docker for okay, let's see. This repository we have on docker-compose.yml, and then we have post this. Okay, let's see. Actually, price for those. Let's comment it out, and then no. So this is something that wait a moment. This is not coming from this one. This comes from the build to create task to containers. From where is this coming now? Render issues. Render issues. Yeah, we have started as it. But earlier we saved this file as well. This is not the issue with the MySQL actually. There's some different issue altogether attaching to it. So see, Postgres is working fine. Okay, what about this? If I just simply I think I got the sense of it. If it works fine, I would have answered. See, it's working fine. Yeah, got it. Okay. So what is happening is actually uh, what is happening is that the image that we have passed here is actually like not being updated. We have updated the image, but it is not actually putting it right. What we do is let's say we build a different image and say we say temp2 and then we do this part and we say okay, we want to use temp2 image. This contains something probably which is spelling is my hunch. Why do we post this now? No. Oh, yeah, yeah, then both should be able to work now. So is my guess. Therefore, it is not okay. Okay, so it says that this image is not created in a local. We did Docker build first API test and then we did test two. First API hyphen test colon test two. Okay, so going to Docker images, this, okay, okay, test two. Okay, Docker compose. Let's remove the Postgres one. We can only here as well. Just let's do this. Why do we need that? Okay, so now we have an issue. Is the issue is it is not able to. Okay, we have do have any type of fast API fast of the images. So we see we have an image known as fast API hyphen test and then oh my gosh. Okay, this should be temp two, not test two. Cool. Now it is working fine. Now everything is working fine, right? So this was the issue, the image issue with the this image particularly. Okay, cool. So you see, I mean, now if you see everything is working fine, right? Now I have a Redis working up. Now I have my backend is actually working fine. And the best part is, you see, I am able to access it right away. I mean, I don't have to do any of those any of those things, fancy things in the so yeah, it is simpler way to have things in general, right? I mean, instead of running Docker compose run, I can simply define a Docker compose file, and usually these are not some any different parameters. These are all the parameters that we can by default pass when we run Docker run command in general. Those are like not very different things to shape. I mean, we can pass this thing when we do Docker run. We pass this thing when we do Docker run and so on. And we can also pass this environment variables when we do Docker run. But now we see this is a specific. This is a much better way. Right? We have all the things inside specified inside this YAML file, and then we are able to do it. Again, should the name be Docker Compose .yml? Yeah, I mean, uh, by default, it is looking when we do Docker Compose, when we do Docker build, right? It is looking for Docker file. When we do Docker Compose up, it is looking for by default, it is looking for Docker-compose .yml file. But is it recommended to use it? And no, I mean, you have to define your own file, and what we just have to do it. We just have to pass the file explicitly. So what we do is we can simply say let's just stop it and I can simply say something like docker and then compose minus file or minus f to say and then I can say something like docker compose because I'm using this file as of now it will just work fine and then I say okay and this will just work fine so I can pass this file and I don't have to worry about the dot and so on it does not matter right And for now, this is much simpler in general. Now, if you see, I mean, I'm seeing all these things in a single page. I'm seeing mixed logs, and whatever we are seeing here is actually the name of the service, right? These are all services. If you see, right, these are all services. I have defined four services, no, and all those four services are actually being done right now independently, and all the lines are being prefixed by the name of the service. So this is the name of the service, and this is the name of the service. Is actually hyphen one is actually the name of the one container. So again, I have an option to specify. For example, if I feel like I need two backend services, I can explicitly say I can explicitly specify that instead of one backend service, I want to run two backend services. How do we do it? Let's just check the documentation. Docker compose specify multiple containers, right? And it should give us there's an option of replica specifying how many replicas we want to run. And I think we should be able to see it right away. No, no, this should specify how Docker Compose run multiple replicas. The Compose replica. Okay, so I think it should give us. Okay, so we have an option of replica, right? So I can simply come here and explicitly say, okay, for this service I want to run, let's say two replicas. I think the Okay, property replicas. I think the definition is changed now. I think so. This was 3.7. This is 3.8. So let's head to the Docker Compose documentation maybe. And this is the documentation, right? Docker file reference now. Let's reference the file document. Docker Compose file reference. Docker Compose, Compose specification, and then we have simple up level. We all those things we already seen. Compose build specification we have seen. How do we run multiple replicas of Compose 3.8? Okay, so there is a new thing now that is scale. Okay, okay, cool. So you see now the things have changed. The syntax has changed now. So now we have to specify it like this, I guess. Yeah. So this we specify. Okay, yeah. So now when I do this, I will simply stop this thing, and then I will do Docker Compose up, and then we'll be able to see we are having three different replicas of this particular service. So Docker Compose up. You see, right? Right? We see. We have only single replicas for. Okay. Oh yeah. Okay. Sorry for that. Yeah. So right now you can see that. all those ports that we pass, those ranges are available, right? And those are allowing us to connect to different ports that we have. I think my port is not, yeah, because we have three services and we have passed four ports. Dual edition is also included. That's why we are not able to do it. But yeah, you get the point, right? So we do it. But again, uh, uh, one genuine question is obviously how do I map to a single port so that instead of this service I mean instead of me specifying different ports, my load balancer should be able to identify and map different ports to should explicitly say, so I just access the 88 port and based on the, based on the load balancer decision, it points me to different services. I think, okay, so screen share is also changed. Let me show it again. Okay, sorry. Okay. I don't know how things change automatically. Okay, I'm audible now? Am I visible now? Okay, good, right? So you see, now if you see here, yeah, I mean, I'm able to use it, right? So because I shared the ranges of the code. Now all they are being pointed to this thing. One genuine question which I will repeat it again. One genuine question comes to the mind is is there any way to specify only single port so that my load balancer actually decides and it actually handles those things. I mean, I don't want to understand. I don't want to care about how many replicas are running. I just want to access one pod and it should point to different pods or containers that are running inside. So yeah, that is one good question that we have. We'll see in the last, but this is how we do it. If you want to run the multiple containers now. Now again, we are running it on. We are not running it on a directory mode, right? We are running in a live mode. The moment I say Docker Compose, I mean at the moment I stop the do Control C, everything stops in general, and now I won't be able to access it. Right? So how can I run it in a detailed way? Yes, I can run it instead of pass minus P. Okay. Set the schooling port 890 to listens up. Port already in use. Okay. Let's see. Okay, cool. Right. So now I think we were able to use it again. Uh, Again, I'm able to access them, all of them, as I have specified mentioned over there. Now, how do I I mean, how do I check the logs in general? So I mean, you don't have to do anything fancy here. We for looking logs of the Docker, we did Docker logs for Docker compose logs, we Docker compose logs, and if you give us the logs, right, we got all the logs here right away. And if you want to follow it again, the same thing, minus follow, and then I'm now just following the logs. I refresh it, I will be able to see the I'm able to see the actual log as in general. Now, if I want to see logs of specific service, again do that as well. I can say, and then I can pass the name of the service. So let's say if I say this, I'm able to see the logs of this service. If I do this, and then now I'm only following the logs of that particular service in general. So I mean, now I won't see logs of different service, right? Likewise, for backend, it becomes a bit trickier, right? No, why? Because now we have different services running for it. So I think if I do backend, it will pull up all the three logs, yes. But if I say one, I think it should give me, yeah, okay, good. It is good. It is good, right? So I can see logs of all these files in a single place. No matter which service I'm accessing, I will see the logs there right away. And yeah, so it's fine, right? And again, the same thing. If you want to again, what it does, it actually spins up the Docker container itself. So if you see, when we did Docker Composer, but it is actually doing Docker run inside, right? More like an abstraction layer. So we don't have to do Docker run inside our terminal, but Well, like it is what something that it is doing for us, right? And how do I access it? I can simply say docker compose, and then I can say again, yeah. So sorry, docker exec minus id, and then I can pass the container image, and then I can say bash, and then yeah, it will be right inside that container. It is simple. Because at then it spins up the Docker container, so I can just do Docker PS and like go inside any of the machines, any of the containers in general, and then I should be fine. So I mean, this is what this is what we are able to do. Now we have a section of where you see here one thing will be in this step right now. What we have to do is we have to constantly update this image again and again, right? So what if what if I can build this image right when I do the docker build command, docker compose up command, so that I don't have to build this image separately and do it again, given I mean I'm gonna use it like right here itself, right? So there's a thing called docker compose build context. So we have an option of specifying the Docker file right away, right? So yes, so yeah, so what we can do is inside the image we can simply say build, and then inside it I can say context, and inside it I can sorry uh, uh what is it Docker file. So I can pass a Docker file as Docker hyphen compose or no, sorry Docker file, right? And I can simply say Docker compose up minus C, and yeah, should be able to yeah. So now the every time I will do Docker Composer, it will actually build the image first, and then on it will use it. So that way, I just had to just had to save the file and do the Docker Compose up once only once, and yeah, I mean I don't have to build the Docker image again and again. Oh yeah, it was not a test. So I think it should work now. Likewise, for example, let's say I want to change the image. Hello, new world. I say okay, I stop it again, and then I can say stop because we have ICs. It is going to take some time, right, to stop them gracefully. And then also, yeah, I can do Docker Composer, and then I the moment they are up, it is not yet up. It is making them up, right? So that's why we are still seeing the old one. Once it is up, I think we will be able to see the new logs. Oh, interestingly, we are not able to see it, right? Though we have saved the files, because it is already built the image once, and it is not actually, it has not yet switched the images. So the Docker build, so you see the calls are being made, but it is not actually reflecting the current one. For that, what we do is we pass an additional command. We explicitly have to say to Docker Compose that okay, when we're doing Docker Compose up, if there is a build context, instead of reusing the same image, you simply say minus minus build. And from now on, you will see whenever we run this command, we will have a fresh image every time. So let's let it run. Okay, so it says that I see. So if you see Docker Compose PS, we will see. Okay, so you remember the Docker Compose of MySQL we did earlier? It's still running. So let's say Docker Compose down so that those ports are freed that we were running earlier. And now we do Docker Compose up. Now saying the port should be available. Now, yeah, right. Now we're able to use it. And now once right, we see Docker Hello New World, right? Please come from here. Yeah, this is one way of doing things, and likewise, a lot of times you have to pass environment variables and all, right? So instead of passing all the environment variables, we have two options. I mean, I can either specify the file name where all the environment variables are available. For example, for me, this is for me this is .env file where I explicitly identify all the environment variables. Mind the spaces. There should not be any space because the moment you put the space, I mean, it won't become an environment variable. So there should not be any space in between the this equal assignations, assign sign. And explicitly, I can modify this individual environment variables as well. So yeah, I mean, if I don't put here, it should just work fine because by default it is looking for this particular name inside this thing, inside this image. But you will see that I have different environment variable names, and that's why I explicitly identified it. But otherwise, if I rename these environment variables to these ones, I mean, I won't have to do this part again and again, right? So, yeah, again, just to show you different ways of doing it, this is how we can do it in general. And yeah, that's how it works. For example, now the second question might come to you is, how do I, because my database is also running inside this thing, how do I actually connect with, how do I actually connect my backend with the database running in the Docker compose itself, right? So there are two parts. One part is, what we can do is we can expose this thing to, so that the local, system can access the port when, as you are doing it with Docker, right? Or with this part. So we right here, if you see here, what we are doing is we are exposing 3306 port to the system. I mean, I can actually literally okay, just for the sake of it, let's just try to log into the MySQL database that we have created. So you might also know, yeah, let's create a database, right? I will go here and I will see the source. I want to use MySQL as MySQL. And then what is the, because I have exposed the port, I can access it, right? Remember, because we have explicitly exposed the port. So okay, what do we need? We need host. Host is fine, and then the port 363 I can find. For this username and password, we need MySQL user is MySQL. We say okay, and then the password is this some string, and then okay, that's some of this drivers. So it does not complain. So, okay, now test the connection and everything is fine. We should, okay, it is able to connect, right? I just say okay. And yeah, I'm able to see it now. So we are able to see this thing. I simply say, okay, I want to connect to this database and I want to introspect it so that I can actually see it. And then inside it, okay. So inside this, I should be able to see all the tables, which I'm not able to see as of now. Introspect now. This concepts. Yes. Okay, it's just still refreshing. Let me refresh it again. So, I mean, obviously we've not created anything inside it, so that's a reason why it might be empty. But yeah, I mean, if we create anything, we should be able to see it, and you see the real-time logs as well, which we are doing, right? So the point is, yeah, the database exists, and we are able to actually use the database, and yeah. So how do we connect to this database, right? For example, if my Apache API server is running, like something like this, I mean, not inside the container, then I can simply ask it to connect to the localhost database. I mean, MySQL with host is localhost, so that it actually does a port mapping. But in case if you're running it like this, then you have to understand how do these services communicate in between, how do these services communicate among themselves? That is a bigger question that we have, right? So we have a we have like very simple solution for it actually. What we have to do is in like everything will remain the same, just that the host name is something that changes in here, right? For example, if I want to call database service from inside my backend code, what I do is in the MySQL host, I don't pass the local host or any random IP. I pass CMS hyphen MySQL as the MySQL host. For example, environment variable can be something like this that I would pass, and then in the MySQL host, MySQL let's say host, instead of putting anything, I will simply pass something like CMS hyphen MySQL. Now, the Docker has a DNS system inside of it already, right? I mean, as in known address, wonderful, readable file. Okay. So, there's a inbuilt DNS server inside of Docker. What do you mean by DNS? Domain name. Resolution, I think something like that is DNS server. I might be wrong with that with the last part, but domain name resolver DNS server is already running inside the Docker file. What it does it actually is it tries to look. For example, when you say I want to connect to the host, for example, I mean there are two ways to connect to something, right? Either by the IP address or by the domain name, right? So, for example, if I want to connect to localhost is one of the reserved domain name that any system already, every system already has. If I want to open Google, I simply say, okay, google.com, and this is how I connect to the google.com, right? Likewise, when I say I want to connect to this random host, what it does it actually is actually first looks locally whether do I have any other service with that particular name as same as the host. If it does, then it routes any of the calls to that host to that particular service. So, for example, if I say I want to connect to the database with host as CMS MySQL, this backend will actually connect with this database only. If I change it to some different endpoint, like some actual cloud server deployed on AWS, GCP, or Azure in general, then it will again look for the the host name that is passed. When it says that there is no such mapping service that we have locally available, then only it will allow the call to leave the local Docker system, and then the call actually will be made to the actual database server. But if it is able to find this particular name inside the services, then we can we can access it right away. That's how we can access the RabbitMQ. That's how we can access the Redis as well. It is that straightforward. I mean, yeah, we just pass the host name as the name of the service, and likewise, for example, if let's say we had different service, something like backend, let's say we had a different service which communicates to us. Let's say fast API, right? Now, what if, okay, let's make it, let's receipt, CIPT, receipt generator, and let's call it backend, right? Now, what if backend wants to call this receipt generator service engine, right? It just had to call HTTP colon slash s CMS hyphen escape hyphen generator, and then the port that is attached with it. And the Docker Compose will ensure that that call is actually mapped to this service and not any random place in the instead of everything out. So you got the point, right? And that's how we do the inter-service communication in Docker Compose. And that's how easier it is in general. And yes, I think this is it. Let me see. Yeah, we have seen about the logs part. We've seen about and that's how you can easily create your own developer environment fast, in a faster way, right? In general. I mean, yeah, I just create the Docker files and all the images are not separated. If anything goes wrong, we don't have to purge everything. I don't have to do brew install, uninstall MySQL, brew uninstall Postgres, or apt uninstall things. I can simply say, okay, I can simply cut this off, or Docker compose down. Sorry, typo, Docker compose down. What it will do is it will actually remove. So if you say Docker PS, now nothing is running in general. So all the services that we had created, now they're all gone in the flash in general, right? And yeah, I mean, my system is also intact. I mean, yeah, I don't have to. I did not install MySQL or Postgres explicitly, and things are were working fine in general. So yeah, folks, this was it. I mean, if you have any other questions, we can talk about it. If there's anything that you would want to discuss about, or any questions or any ideas you would have, probably you can discuss about it. No. I'm not able to hear you, Abhishek, if you're saying anything. Is anyone saying anything? Okay, no. Okay, so yeah, I will share the feedback form as well. If you feel like giving some feedbacks, yeah, please feel free to and let me know. I mean, if I can, I mean, if I can be of any help. Okay. Also, you can put comments on the videos, respective videos on Twitter and YouTube. If you have any questions, I can help you there as well. Okay, folks, then see you. Have a good weekend. And those folks who are actually in Raipur and nearby area, next week we will be having a physical meetup of our April meetup in the city. So do feel free to join us. We'll be rolling out the announcements in by tomorrow or like by Monday. So have a good weekend. Have a great weekend, folks. Happy to connect and thank you so much for joining. I hope you learned something. Bye.